Good afternoon to all my YouTube viewers. In this video, I like to discuss about capacitance. It is an extension video of the previous videos, and from here we can learn about capacitance, especially spherical, and how other different type of arrangements we have to handle. That sort of things will come in this video. And first, let us start the job. You must have pen and paper with you, so that whenever there is a doubt you can clarify by repeating videos. Now here we have shown three concentric spherical shells. Shell B is earth, and shell A has given charge small q, and shell C has given charge twice small q. Here small q, here twice small q, and here nothing is given, but we can assume that here charge will be q dash. We have to find out, say, charge on B shell. Say this is q dash. Then how to distribution of charges takes place? I like to show another diagram. First, q given here, so due to induction it will be minus q, and to balance outer charge and inside charge, that means here it will be plus q. That means on B surface it will be q dash plus q, and due to induction this whole thing will come on this inner surface of C, that will be minus within bracket q dash plus q. And because of you have to balance between this charge and this one, whole thing will come as a positive here. This is the way charge distribution you can arrange. Then you can solve problems without any difficulties. Let us start today's job. Now here problem 1, a charge small q is distributed uniformly on the surface of a sphere of radius capital R. It is covered by a concentric hollow conducting spheres of radius thrice r. Find the charges on inner and outer surfaces of the hollow sphere if it is earth. According to question, outer surface is earth, which is 3r distance away from the center, and inner sphere is radius r. Small q is given on inner sphere. As we have discussed earlier, because of induction, inner surface of the big sphere will be minus q, and outer surface will be q dash. We have to find out that unknown q dash. Now, as we know, potential on earth's surface will be 0. I mean on outer surface of this concentric arrangement. Now if we find potential there, we will see it will be q by thrice r, because radius is thrice r, plus minus q divided by again thrice r, because it is on the surface, that is the distance, plus unknown charge q dash divided by thrice r will be give 0. I mean solving here, you can see inner surface will be for outer sphere is coming, inner surface of inner sphere is 0, outer surface is q, and for the outer surface of the other one is minus q, and 0 is coming. So now you can see that the inner surface of the small sphere is, there is no charge, 0, and inner sphere of the big sphere, that is minus q because of induction, and for the outer surface of the small sphere it will be plus q, and the outside is q dash, which has come 0. Now next job. Three concentric spherical shells A, B and C of radii are twice bigger and thrice bigger. Shell B is arced. A and C are given charges Q and twice Q respectively. Find charges on all the surfaces of A, B and C. We have to find out all the charges. Now, important point is that sphere B is arced. That means potential will be 0. Now, for sphere A, total charge is involved only Q. That means potential for a B position on surface sphere on sphere B, it will be 1 by 4 pi epsilon naught within bracket Q by twice R. Radius is twice R for Q charge. Then on sphere B, it is assumed that Q dash will be the amount of charge. Now, if you see, you can see that the total charge involved here is minus Q. Here it is plus Q. This will cancel. Only Q dash will be there. That means Q dash divided by twice R will come. Plus in outer shell again you can see twice Q charge was given. Then because of induction, this will be the totally minus, that is within bracket minus Q dash plus Q inside, and outside will be redistributed. It will balance with this one. That means just plus of that one. Summing all, ultimately you will get only twice Q. Sum all the charges involved on outer bigger sphere, outer charges, inside charges. If sum of these two will give you only twice Q. That means net charge is twice Q divided by 3R is the distance. Therefore, we can find out Q dash will be, after solving this, we can get 7 by 6 Q by R, 7 by 6 Q by R, and 7 by 3 will come, 7 by 3 Q will come. That is a small mistake. You can see Q dash will be minus 7 by 3 Q. Then on sphere B, charge will be how much? Because Q dash plus Q. Q dash means minus 7 by 3 Q plus Q. Summing this, you will get minus 4 by 3 Q. That is the amount of charge involved on surface B, outer surface of sphere B. Now we can have a table like this, where you can see all the charges. On surface, inner surface of A, there is no charge, 0, and on B, inner surface of B will be minus Q, and for C sphere it will be minus 4 by 3 Q, and outer surface of A, of course small q is given, that is there, and on outer surface of B will be minus 4 by 3 Q, and outermost of C will be twice Q only. And in this job, three concentric thin spherical shells ABC of radii A, B, C respectively, the shell A and C are given Q and minus Q charge. Previous problem Q and twice Q, now it is Q and minus Q respectively. And the shell B is arced. Find the charges appearing on the surface of B and C. We have to find out surfaces of B and C charges. Now let us the outer, we can say charge as it is understood that it is initial charge is Q, then it will be minus Q, then it will be Q dash plus Q, and then whole divided within bracket minus will be induced here, then everything will be plus there. That means summing total charge we have to look for how much charge is involved here. Now charge distribution is understood. Inner surface of outer surface of A will be Q, due to induction on B inner surface will be minus Q, and on this outermost surface it was taken Q dash, that means Q dash plus Q will be there. Then due to induction for the inner surface of C will be minus q dash plus q, then whole thing will be plus, that means plus q dash plus q, are already minus q has given here. So ultimately we will get here q. We have to see how much is coming there. Now as it is according to question, that means here it will be on outermost shell only q dash charge is observed, and inner of sphere shell B C will be minus q plus q dash, and for B outer will be q dash plus q, and inner will be minus q dash, and it was given. Then we can automatically we can go for potential. Potential is known, that is V 1 by equal to 1 by 4 pi epsilon naught. Charge for inner charge on shell A divided by distance. We are calculating potential on B shell, that means B will be the distance, plus on shell B is q dash charge divided by B, plus the outermost charge is only minus q, that was given in the problem, that is minus q over C will come here, that will be equal to 0. Solving we can get q dash will come q within bracket B by C, small b by small c minus 1, and on surface C will be q dash, this is the amount, that is q within bracket B by C minus 1, and on surface B will be q dash plus q, that will come, that will give the q within bracket B by C. Job number 4, 3 conducting and concentric sphere shells of radii r, 2r, 3r carry charges q minus twice q plus thrice q respectively. Find charge distribution of the spheres. Now as it is given in the problem, on sphere A it is q, as it was discussed, due to induction on inner surface of B will be minus q, and outer surface will be already it was given minus twice q plus q. If we then due to induction the other one will get net charge here will be minus twice q plus q, I mean minus q, that means due to induction it will be plus q inner surface of C, then outside will be minus q plus 3q given, that means net charge will be twice q. So we can find out net charges on each shell. Charge on shell A will be only plus q, charge on inner surface of shell B will be minus q, and outer surface will be again minus q, because minus twice q charge given there, so it will be minus q. Just go through this, that's why I have given this problem, so that you can clarify with other problems how it is coming. Now on surface, inner surface of C will be plus q, because due to induction, because on surface B it is minus q, so due to induction it will be plus q in inner surface. Then again it will come out as a distribution will be like that, it will balance between outside and inside of the same shell, that will become twice q, because their charge given here is thrice q minus q, that means it will be twice q. Check this and you will learn lot of things here. Now potential on A we can calculate, on A it will be q divided by charge divided by radius. For the B shell it is minus twice q divided by radius, because net charge on B is minus twice q by B, and plus net charge on shell C is thrice q by C. So solving we can get potential here. Now similarly on B surface, when B will come, denominator, that is q by, it will be b for inner shell, q by b, then plus minus twice q by b, b is the distance now, and for the outer shell 3q by c. We know that it remains constant throughout the up to center to surface, it will remain constant. That value is charge divided by its own radius, so it is not going to change. That we have to then come to on shell C. All the radius which is it will be C only, because we are going to calculate on surface C. So for sphere shell A, it will distance will be radius C, and for charge on shell D, distance will be again C, and on third shell, that is C, will come. Now potentials are available. Determine the current through the battery. Number 1, current immediately after switch S is closed. You can see one circuit diagram given. There are two capacitors C1 and C2, and there are three resistances. One cell is there, EMF is E, and a switch is S is there. Now when switch is just connected, t equal to 0, we have to find out current. That means just immediately after connection, that it means we know that at t equal to 0, capacitor are the short circuited route, it is short circuited, I mean no resistance is there, so current will follow that path. Now if you see here, with capacitor C2 there is a resistance, so easiest and the least resistance path will be E, R1, C1, S and E again. That means current will be through C1, it will be E divided by R1, E divided by R1. Now next question, after a long time, I mean when it will reach to steady state, that means C1 and C2 will be a open circuit, I mean the current cannot pass through this route, only current can pass through that E, R1 via 3 and then S, then E, I mean total current will be in this case E divided by R1 plus R3 will come. When C1 and C2 are both open. Now next job number 6. Just after S is closed, find out current through R1 resistance and R2 resistance. Now as earlier, here is a capacitor in the line of R2 resistance, I mean when switch S is closed, immediately it will then current through R1 resistance will be E divided by R1, because potential drop across both the resistor will be same, because C1 will allow current flow, because it is when t equal to 0, it is a short circuited, C will be can be considered as a short circuited, so current will flow through R2 also, that means IR2 will be E by R2, because potential drop will be same for both the resistances. Once it is ready, steady state reached, it means current through R2 resistance is not possible, because capacitor won't allow current flow, so only current will be available through R1, that is E by R1, E by R1, R2 will be 0, it will become open circuit. Job number 7. In this circuit, two switches are there, S1, S2, one capacitor with resistance R1, another capacitor in between S1, S2, that is C is the capacitance, and there is a two cells are there, one is E, another EMF is twice E. Twice E is connected with R2. Now S2 close for fast and keep close for long time. I mean S2 will be closed fast and this capacitor will be charged to maximum extent. I mean this one will be charged to maximum extent, total charge will happen because enough time is given here. That means this capacitor is fully charged long time, so capacitor will be fully charged, and that amount will be potential drop across this will be twice E, because after completion of charges, once it is steady state is rest, current cannot flow through R2. Current won't flow through R2, it will pass through this circuit. I mean after steady state current won't flow through this circuit. This capacitor is totally charged, potential drop will be twice E. So charge accumulation will be there. I mean potential at this point will be twice E. Potential here is twice E, capacitor is totally charged. If we say this is 0, potential 0, 0, this will remain 0. Now thereafter S1 is closed. Find current through S1 just after S1 close. Now it is found that potential at this point is twice E, and here it will be its potential will be, once it is connected, potential here will be E only because its EMF is E. Then this has a higher potential than this, that means twice E minus E divided by this resistance, because this will allow full current, short circuited current. That means current will be twice E minus E divided by R1 will be the current through this, and current will go positive terminal of the battery to negative terminal, I mean left side of this circuit. And current amount will be E by R1 towards positive to negative side of the battery. Here potential is twice E, once it is completely charged, potential here will be twice E, here it is, once it is connected, S1 is connected, E will be the potential here the potential is twice E. This has higher potential, this has lower potential, so this minus this will give current in this direction, divided by resistance will give the amount of current. E divided by R1 will be the amount of current from right side to left side, I mean positive side of the battery to negative side of the battery. That is the point here. Which of the following conditions is correct in the steady state? There are conditions given, 4 conditions: R1 C1 equal to R2 C2, R1 by C1 equal to R2 by C2, R1 R2 equal to C1 C2, and number D, none of these. And seeing the circuit, we can see one steady state, most important point is steady state. That means capacitors are totally charged. That means current cannot pass through these capacitors. So current has to pass only if battery is connected, current will pass through R1, R and R2 only. That means it will be in series form. So there cannot be any relation between C1 and C2 and among R resistances. That is not possible. In steady state, both the capacitors are fully charged, no current will flow through the capacitors, so capacitance and resistance have no specific relations. The answer D will be the correct choice here. Now next question. A 2 microfarad capacitor is charged as shown in the figure. The percentage of its started energy dissipated after the switch S is turned to position 2. I mean switch is initially connected here at position 1, thereafter once it is completely charged, thereafter it will be shifted to position 2. That is the meaning here. That means that charge accumulated in the charge accumulated in the capacitor will be CV, that means C is 2 microfarad into E is the EMF, so twice E. And once switch is shifted from 1 to 2, there are two capacitors, one is 8 microfarad, another is 2 microfarad. Therefore, they will be parallel. I mean total capacitance, equivalent capacitance will become 10 microfarad. That is to be noted. Now, as charge is not going to lose other way, it will remain same. It will redistribute among the two capacitors. That means a new energy level will come, that is energy final, that is half total charge is twice E divided by 10, twice E square divided by 10 will be the energy, half twice E square whole square divided by 10, that will give us E square by 5. Then change in energy, that initial minus final, that will be the initial minus final is less, that means there is a deficiency, I mean dissipation of energy takes place. Now if you subtract this, we will get 4 by 5 square divided by initial energy was E square into 100 will give the percentage loss, and it will be 80% loss will take place. That means answer D is correct here. Important point here, when switch is shifted from position 1 to 2, you have to take care of resultant equivalent capacitors. That two capacitors are there, they will become parallel. You have to add. Now job number 10, at time t equal to 0, a battery of 10 volt is connected across points A and B in the given circuit. If the capacitors have no charge initially, at what time, in seconds of course we have to find out time, at what time does the voltage across them becomes 4 volt? I mean across the capacitor potential drop will be 4 volt. We have to find out at what time it will achieve. That is the point. Now simplified diagram will be like this, that parallel resistances that will give us equivalent 1 mega ohm resistance, and here it is 2 and 2 parallel capacitors, that means it will be 4 microfarad. Now that circuit diagram is available. Now we know voltage varies. This is the standard equation when voltage varies when you will charge a capacitor across capacitor, voltage will gain in this fashion, that is V as a function of time equal to V naught bracket 1 minus T by tau. T means time, which is depends how much time we are providing, and tau is a time constant, that is a product of resistance into capacitance, that is tau equal to tau we can calculate, that is resistance is 1 into 10 to the power 6 ohm into 4 into 10 to the power minus 6, so it will give 4 seconds. It will come in that unit will be in seconds, 4 seconds. Now we can substitute in this equation. We need to get V as a function of time, that will be 4 volt, that is our data available. Now that will give initial battery supply is 10 within bracket 1 minus e to the power minus small t by 4, time constant is 4 seconds. Now solving this one, how to solve? 4 divided by 10 will give 0.4 and then it will bring e to the power minus t by 4 left side, it will give you 0.6 because 1 is there. 1 minus 0.4 will give 0.6, that means 3 by 5. Once it is available, then take log in both the sides, ln or log e base, that will give us minus t by 4 log e base e will give us log 3 minus log 5, and these two data is given in the problem, that one is 1.6 the log ln 5 and ln 3 is 1.1. Substitute, we can get time will be 2 seconds. Now job number 11. For the circuit shown in figure, there are 3 switches S1, S2 and S3. S3 is in between, and there are 2 capacitors. It is already charged with V1 voltage, that is 30 volt, and capacitance 2 picofarad, and another capacitor already it is charged 20 volt across it, and C2 is 3 picofarad. There are 4 statements given. First statement is with S1 closed, V1 will become 15 volt, V2 will become 20 volt. Suppose S1 is closed and the 2 ends are earth, there is no source here. So already capacitor is charged. Each capacitor will hold, each plate of this capacitor, C1 capacitor, will hold 60 picocoulombs of charges. Left side will hold 60 pico positive charge and right side will be negative charge. In this way, the other one also 60 picofarad for capacitor 2, that is also 60, that is not coming now. Here these charges are existing, plus q then minus q, and S1 is connected. Now due to this, is it possible that voltage will change for the C1 and C2? Not possible. It is not connected at all. That how it will change? Because of interaction forces between the 2 charges, positive charge and negative charge, it won't going to change any amount. So statement A is wrong. And then with S3 closed, suppose S3 is closed, can it change again potential drop across the capacitor 25 volt? Not possible. B also wrong statement. Number C, S1, S2 closed. Now end capacitors are closed. This one, this switch and this switch is closed. Now what will happen? These charges are this side positive, this side negative. Similarly, this side positive, this side negative. What will happen? Because of mutual forces, it won't change their charges. So question of potential drop cannot change. Here given V1 equal to V2 equal to 0, that is impossible. Next D, with S1, S3 close, V1 will remain previous voltage, V2 remain. It is justified because voltages are not going to change, because neither capacitor is changing nor the charges are changing. So question of voltage cannot change. So D is most corrected answer, but in the question nothing asked beyond this. But if question asks that all 3 is connected, then it may that this arrangement will be a parallel combination, or it may be series combination by seeing the charge distribution among the capacitors. That will decide whether it will be series or parallel. In many problems we have solved earlier video that that becomes parallel under that certain condition. Now this problem D will be the answer. Now job number 12. 2 concentric metal spheres of radii smaller and bigger respectively are maintained at a potential difference V. What ratio must the radii have for minimum voltage gradient in the intervarying medium? Intervarying medium. for a given value of r. That means we have to find out relation between smaller and bigger. We know capacitance for a concentric two spherical shells 4 pi epsilon naught smaller bigger divided by bigger minus smaller. Now from here, as it is in the question, it is being told, we know that E equal to minus dV by dx, that is called potential gradient. I mean E will, here in this problem, E will be a maximum at certain point where if we differentiate we will get 0. To get minimum potential gradient, we have to differentiate. Anyway, first we have to find out E. E we can find out with the help of Gauss law, that is charged by E dot flux equal to E dot ds closed integral equal to q by epsilon naught. Already we have seen that q for this one will be 4 pi epsilon smaller bigger divided by bigger minus smaller into V is the potential drop between the two shells. That means charge is available divided by surface area, that means 4 pi epsilon naught here this one 4 pi epsilon naught r square into epsilon naught, charge by epsilon naught divided by this one. This gives electric field, that is known from Gauss law. Now we can put q from here, we can substitute here, our expression will come smaller bigger V divided by r square, this one r minus r. So simplifying we can get bigger V divided by r bigger smaller minus smaller square. This will be the expression. Now we have to find out dE by dr, which for 0 it will give maximum gradient position. That means after differentiation we can see differentiation will be like this. We can do this differentiation, that will be 0. We have to make it 0, then smaller is coming bigger by 2. I mean potential gradient will be minimum when it will be at smaller equal to bigger by 2 position. That is very important. This job is good job, take care of it. And differentiation also easy, because upper part you can see here r and v both are constant, that will become 0. Differentiation, that this one minus this into this, this expression will come, and this once you make it 0, that means the smaller equal to bigger by 2, potential gradient will be minimum. Thank you very much for good listening. Now these type of problems will help you to get certain level which will require for competitive exams. Now only seeing this video you may able to solve problems for today or tomorrow, but check whether you are really able to control it or not. You have to practice many times, otherwise you are taking care of many things but not gaining anything. That won't give much benefit. To benefit you must do parallelly yourself, that you check whether you can do this or not, that you will understand that you are not able to do or you are able to do, what extent you are able to do. All these things is in your control. Once you can satisfy from that end, definitely your achievement no one can stop. Thank you very much for good listening.